right, hello everyone, and welcome to our final workshop of the Road to the Metaverse Creator Series. In today's session, we're going to learn how to leverage your users' real-world location in your Unity apps. Just in case this is your first time joining us, my name is Drew Demokis, and I'll be your MC for the session. I joined Unity back in 2020 as a creator and developer advocate, mostly focused on showing businesses how AR and VR can solve old problems and modernize old processes. Now I'll pass things around for intros to our hosts, starting with Jerome.
Hello, everyone. I'm Jerome Moredolon. I'm a senior creator advocate here at Unity and co-host of this series plus the Live Learn. Welcome to this last episode, and I'll hand it over to my partner in crime, Vanessa.
Hello, I'm Vanessa, and I've been at Unity for, I lost the count, like 6, 7, 8 months, something like that. And I'm
so
the
long.
baby of the team. Yeah, for me, yeah, it feels. I can't believe we're finishing. And my background is in computer game development. And now it's John's turn.
Hello, John Futcher. Been with Unity a number of years now. I've been using Unity for over a decade, building video games and things in industrial spaces, and I'm here for technical support. Not that these folks really need it.
All right, awesome. Thanks, Jerome, Vanessa, and John. All right, so just going to get a quick bit of housekeeping out of the way, so as everybody can see, we have today's agenda on display here. So following a quick introduction, we're going to go into the main topic. So before we get started, as usual, if you have any questions at all during the session for us, please type them into the Q&A pod on Zoom, just the easiest way for us to find all of your questions. This session is also going to be recorded, and there will be an on-demand version of this uploaded in just a few weeks. Now, as always, we're always looking for to hear from how we can improve our presentations from you, the audience. So we have a survey available for today's live session. It is available at the QR code on screen, as well as at the link I have in the chat here. So please fill that out when you get a chance. It's a huge help for us just to show how we can improve our presentations. Now, before we go on into our main topic today, I'd like to quickly shout out an upcoming event, Creator Day Industry. This is coming March 31st, 2023, just a couple of weeks. This is a half day of webinars featuring talks from Unity experts in our creator community. So if you've attended our previous Creator Day in December or any past digital developer days in years prior, you can expect a similar format. Only there's an emphasis on celebrating and inspiring our creator community. March's session features talks related to digital twins, the automotive design space, AEC industry, VR for sports training, and much more. You can check out the agenda and register at the link and QR code. Again, link is in the chat and QR code is on screen. And with that, I'll hand things over to Jerome.
Thank you. Let me grab the screen share. There we go. And we should see the same exact slide. And I'll go to my notes. All right, that sounds like a fantastic event. I can't wait to watch it. Anyway, I wanted to, as Drew mentioned, today's is the last episode of the Road to the Metaverse Creator Series. But don't despair, there's much to do, still a lot to learn if you want to. Our colleague Joy from the education team just released a new pathways. There are multiple pathways that you can follow, but there's a new one focusing on augmented reality and using visual scripting. So really in line with what we've been trying to do for the past year. As you can see, efforts continue to help you on your journey to create the next generation of application for the metaverse, industrial or not. And this pathway is an absolutely brilliant way of getting started. There's a few actually others that JoyApp is driving, and it's absolutely brilliant. Next up, a really fantastic update to our friend at the XR Interaction Toolkit. If you have joined us for most of the AR and VR sessions that we've done, we've been using the XR Interaction Toolkit, and version 2.3 has been released. It's a major overhaul of the framework, including improved two hands, for example, manipulation from objects, improve hand rendering, by the way, directly inside XR Interaction Toolkit. You don't have any more dependencies on other SDKs. You can use the default hands, and improve device simulator. If you don't have a VR headset, but on hand, for example, you're traveling or something and you can't set up your Vive Pro i2 in the lounge at the airport, where you can use this new device simulator in order to test your interactive setup inside Unity. So really good overall 2.3. It's available. There's a blog post that I link here, and we'll share the slide after this session as usual on the forum. And there is also a updated sample project, which has been released, version 2.3. I think that was last week. So right off the press. Right, today's session is about geolocated experiences, social or not, basically being able to share geolocating content across users through applications created with Unity, and focusing on augmented reality. The original pitch for this session was to look at what Niantic has done with Pokemon Go, so geolocating content and allowing users to find it with their mobile application using both geolocation and cloud anchors, as we're going to describe it. But to start, Vanessa has been exploring a new release. Sadly, if you follow the series also, you probably found out that Altspace VR has been shut down by Microsoft. This was a really popular social platform, similar to VR Chat, I guess, where you could create content. And just like VR Chat, you can also create custom content inside the Unity editor. And sadly, we lost that avenue of content creation. But Spatial, another metaverse platform, has released a Unity SDK, and Vanessa has explored this in details. Would you like me to drive the slides?
Sure.
Yeah.
Let
So
me
next slide.
Wait, shall I steal it from you?
If you want.
Yeah,
Yeah, go ahead.
why not? Let's go.
You're in charge.
Share. And yeah, so Spatial. So basically, Spatial is a platform that allows you to create your own virtual avatar, your spaces. So you can organize all these live events and you can interact with others, as Jerome said, in the metaverse environment. Now, as you can see on the screen, the Spatial Creator Toolkit includes a variety of tools, 3D content creation tool, spatial mapping tool. You have as well gesture recognition engine, a lot of different stuff. So these tools allow you to create and deploy these experiences very quick and very easily without having to, without needing to know complex programming languages or even specialized software. And what it does is this allows you to create a wide range of experiences, interactive games, training simulations, showcases, whatever you can think of. So as Jerome said before, is because old VR is gone, I think this is a fantastic substitute. And then in the next slide, my last thing for you guys is I put some instructions on how to set up the Spatial Creator Toolkit for Unity, where you can test the active scene into your web. And as I said, you can create everything in Unity, avatars, environments, bring your assets and deploy it. And it's fantastic. I went into it with my headset as well, and I had a lot of fun in Spatial. You should definitely try it.
Nice. Is that your avatar that we see on screen?
Yeah,
there?
yeah, that's me. I created that myself. Yeah, it's
That's
great. The
all really cool.
personalization is amazing.
And you just download the template, open it inside the Unity editor, and you're good to go?
Yeah, you have a lot of templates. Basically, just follow all these instructions, click a few different things, and it's ready to go. Very easy to follow along.
Oh, brilliant. Thank you, Vanessa. I guess I'll grab the screen share again. There we go. A lot of handing off today. You should see the slides, hopefully.
Yep.
Geospatial SDK. All right. So next up, geolocation, quite important. We've covered mapping previously in this series extensively with the Bing, for example, implementation, the Bing integration with Unity specifically for HoloLens. So we have 2 episodes where we used Bing Maps to integrate inside our Unity applications. You can go back to watch those. One was on ingesting weather data, and the other one was creating a AR application for the HoloLens. So we use a similar setup as the map that you see here on the top image. These are some of the popular integration for Unity when it comes to mapping. I also wanted to flag this asset on the asset store, 5-star with 201 reviews, extremely highly rated. It's called Online Map version 3 and pretty inexpensive, 80 euros, and allows you to integrate a multitude of mapping backend and functionality like route founding and things like that. inside Unity application. It's a brilliant little shortcut if you want to include maps inside a Unity-based application. You can see here, very similar little avatars that you can place, all kind of 3D content, including, full terrain and things like that. So I want to flag this because this, as usual, the asset store is a goldmine of tools and solutions for you to use. But ArcGIS from Esri, we are working closely with them in order to integrate their mapping solution inside Unity. Mapbox is the same thing. Here is a bit more of an edge case because that's mostly through partners that we work with here. And then OpenStreetMap, Google Maps, and Bing Maps have open implementation for Unity, or things like the mapping solutions that I just showcased. Another turnkey solution to do geospatial content and also social experiences is Lightship ARDK, right, from Niantic, again, the makers of the creators and publishers of Pokemon Go. And they developed a visual positioning system that allows you to track landmarks, for example, in major cities. We wanted to do a demo. Vanessa wanted to do it. Unfortunately, they're not available in Brighton yet. They are in London and other major cities, and this is really looking for precise anchoring of content using landmarks around town in order to anchor this content. And we did a hackathon with them last year, feels like a lifetime ago, and it's a really brilliant way of working. They have a whole slew of solutions, like real-time mapping of the environment, shared AR sessions, and semantic segmentation, where they can, for example, recognize the sky or trees or grass, and then your application can handle this and pop up specific content for this. So this is a really nice turnkey solution that covers a lot of ground when it comes to get started with geolocated content and social experiences with using a mobile AR. But again, one of the limitations is the coverage of the solutions. It might not work in your area, and then you have to result into more homegrown solutions, which we are going to cover next. Unless if we have questions, we're going to jump into our Google Cloud Anchor demo.
Oh, all good. Just a question I'm going to type an answer to quickly, but otherwise, actually, I guess we can just ask it now. Will these slides and links be provided?
Of course, I'll post them in the forums right after the session.
Yeah, and we'll share the link to the forums at the end as well.
Exactly. Yes. We'll share the slide. There's a ton of links in there that I want to be able to share with you and make sure you have access in order to dig further into this topic. So, first demo is Google Cloud Anchors. So these are data sets which you can create inside any mobile application in order to geolocate content, and then use a visual positioning system provided by Google in order to kind of refine the position of that anchor. How it works, there's basically two simple steps, two simple states, let's say, because there's multiple steps. The first one is what they call hosting. So that's terminology that Google provides. These are from their documentation. Hosting is the creation of an actual anchor. So basically you use AR Foundation, AR planes, as we demonstrated before in the series, place an AR Foundation anchor, then you take that anchor and you send it to Google in order to request, for example, a anchor processing. Then you walk around the anchor, get as many feature points as possible. That data is uploaded to Google server. They do their magic, and then they basically save a geolocated anchor for you in their backend. Next, using that anchor's ID, so you get a unique ID for that object, you can then resolve it, which means you can ask Google to compare whatever data feed is coming from AR Foundation, right? From the, or actually in this case, AR Core, the underlying tech. And that AR Core data, or AR Kit data, sorry, because it also works on iOS, is sent to Google. They match basically the real-time data with the cache data that they have for that anchor. And if there's a good match, if it recognizes basically the environment, it will allow you to place that anchor back where you had created it. there is a really good way of getting started, which is, first of all, you need to get the AR Core extensions. These are available for both iOS and Android, depending on the targets on the platform that you are targeting. And then there is, as usual, as we say in this series, check out the documentation, but mostly make sure to check out the samples. There is a complete sample project for persistent Cloud Anchor, which you can import inside your Unity application. That gives you this basically base scene that has the whole experience for hosting and resolving Cloud Anchors. And we're going to look at it right now. So if all goes well, let me make sure. I'm going to bring into view this window, which is a live view inside my phone. So I'm going to click begin, and you can see my desk here. I can start to see planes are being resolved. There might be a little delay on your end. And then here I'm going to place a giant chicken, which is way too big because this was meant to work outside. Then you can see the API is telling me that the mapping is insufficient, right? For this anchor, because I have to walk around the space, etc., in order to resolve it. So I'm going to skip this step for now. And next up, you can basically go to your resolve anchor, find a anchor that was created previously, and then resolve it. And just to show you quickly what that looks like, if I go to the next slide, you would see this was the experience. I was laughing with Vanessa, sending her pictures of my giant chicken in the park. This is on the way to my son's school in the park. We placed this giant hologram next to a water fountain there. And then every day for the past week, I've been walking by and retrieving that data from the Google services. And it's pretty accurate. It actually works really well, regardless of the condition. It's been actually really poor weather here. So, with rain, etc. The anchor resolved and sadly expired. I forgot to set the expiration, and I think they expired after 1 week. So this week when I got back on Tuesday, I think the chicken was gone, which was really traumatic. I don't know where it went. Is it still alive? Is it somewhere else in the metaverse? We don't know. But let's have a quick look at the demo. I'm not going to dwell too much on it on this one because, as I mentioned, this is a sample from Google. So if you go to your package manager, right, and you look at the files in the project, you will find the AR Core plugin. Sorry, am I in the right project here? Yes. No, this is not the right project. That's why. This is another project. There we go. This is the project. Go. Let's go to the package manager quickly. So I'll pop up my notes. Right. You can see I started with the AR Core template, right, in Unity 2021.3. And then if I go into the packages that are my project, you can see the AR Core extensions. These are simply added by pasting this GitHub URL following their instructions, right? And then under samples, you have this persistent Cloud Anchor sample, which you can import. And that provides you all the functionality needed. Now, the only thing I did after that is I duplicated the scene, created a custom scene for myself to make the modification so I don't, mess about with the sample assets provided. Everything else pretty much stayed the same. And the only thing I did after that is if we go to AR Core session and sorry, under Canvas AR View Manager, I just found here the persistent Cloud Anchor, which is by default just a, sorry, if I hide this and go into my scene view, it's just this basically, this little base there. And then I just added our trusty chicken to the anchor, saved it, don't discard changes, and then referenced. The reference now is going to place that updated anchor inside the scene. As you can see, there's a UI that's provided for us already. You have the home UI here, which is basically the beginning. Then you have the resolve UI, which gives you this. And then you have also an AR view and I think the privacy statement. Yeah, exactly. In case your user needs to agree for that data to be sent by default. So if it's a debug build, they won't ask for it. But if you are using a production build, then they will require you to get approval in order to send that data to Google. Obviously, it's private. If you're wondering about this view, I mean the simulator view. So by default, your Unity scene might look like this. This is the normal game view that most people are used to. But then there's this drop down. You can also use a simulator view. And this is super useful to visualize some of the specificity of a phone, right? So if, for example, we have a punch-through camera, so we can basically estimate the safe area for our user experience, right, on this phone, because we can't guarantee that, for example, content won't be obfuscated by the lack of pixels for this camera. And you have here inside the Unity simulator, this is something that comes with the Unity editor, but most people might not know it's there. You can, for example, take an S9 and then get a feel for how it looks. You can look at, iPhone, for example, 8 Plus, and switch between devices in order to visualize how your user experience is going to look and feel on those devices without the need to push. If you need to create new ones, there's actually in the documentation a explanation of how to create your custom devices for your experience. For example, if the ones that we provide, which are pretty out of date, are not sufficient. So as I mentioned, there's two basically modes, hosting or resolving, and the anchors are saved using player prefs and a simple JSON object. So I invite you to check out the instructions, and obviously some of the work in the back to set up this is to follow the instructions in order to get started with AR Core. With the AR Core API, by the way, there's the AR Core Anchor API, and that's been deprecated. There is a new version on the Google Cloud Platform where you can sign up, where you can add the AR Core API to your cloud account, and then there generate a authentication key, which allows you to then you put basically the secure key from your local key store application. That's what you use to sign the Unity application. You put that on the Google Cloud backend, and that takes care of authentication for you, which is really convenient. But you have to set that up in your Google Cloud account before you can work with cloud anchors. So again, if I go back to my slides, you can see here on the left, we are attempting to resolve an anchor, then we find it. In the center, we are sending this anchor to Google platform, right? It's waiting for you to provide enough data by walking around the anchor in order to trigger the cloud create anchor, which is a function that gets called and then allows you to save that anchor on the cloud. And then later you can go and find, you can see the one closer to the water feature here is the one I created later. This one is the original one I had created that disappeared after a week, sadly. And next up, we're going to do something similar, but with Azure Special Anchors. So same difference. Well, actually, maybe I should pause here in case there are some questions.
Sorry, slow on the mute button today. Just one question, kind of a roadmap question. Are there plans to wrap VPS solutions from different providers like Google Cloud Anchors, Apple AR, GeoAnchor, etc., in the Unity AR Foundation to be able to develop once and deploy into different devices easily?
Yes and no, because these are cloud-based services, so it's a bit more complicated than just abstracting an API, like a vendor API. as I'll show right now, technically that Google demo, you can easily strip out the Google Cloud backend call and replace them with the Azure ones. They're very similar, even in the life cycle of the actual application. So I'll show you this. But I'm not sure if that's the type of abstraction layer we can provide easily out of the box for now. Yeah, I think that was probably something that the Mars team was trying to do, but I don't know where we are in any case with those efforts. Yeah, it would be cool to be able to abstract all of that. I agree.
All right, we got just two more quick questions, if that's all right. Can you host anchors from an iOS device?
Yes, yeah. These both Google Cloud Anchors and Azure Spatial Anchors that I'm showing today are available for iOS. Azure is also available for HoloLens, so you can use that in Universal Windows platform in order to place and retrieve anchors from your iOS device, from your HoloLens. But they're both, cross-platform. AR Core, Cloud. Obviously, AR Core is also the specific AR layer for Android, but the AR Core Cloud backend is agnostic and works on both iOS and Android. I'm showing Android today because that's what I have as far as phone, and I don't have a Mac to build to iOS devices, which is one of the main drawbacks when it comes to building cross-platform application. Is you need to at some point jump into an Apple computer in order to build those iOS application through Xcode.
All right, awesome. Okay, one more quick question before we hop back in. Will the chicken squeak?
Yes, actually it does. Well, technically it does emit particles, but if you tap it, it does squeak.
All right,
Thank
awesome.
you. I see we have some people that have watched previous episodes. That's good. Or joined previous workshops. All right, Azure Spatial Anchors. So as I mentioned, it's very similar to Google. You just go on the Azure backend, you add a resource, which is the Spatial Anchors resource. And if you want to add the Azure SDK to your application, you use the mixed reality feature tool, which is a standalone application that you can add to your project in order to manage the package definition, the package declaration for your Unity project, and add the relevant packages. The whole Azure mixed reality SDK is delivered through scoped packages, so it's really in line with the project management of Unity. And here you can see, if I take my laser pointer, you can see that I have added those two under Azure Mixed Reality Services, the Azure Spatial Anchor SDK for Android. Again, I'm developing for Android, but there is a version for iOS and a version for Windows. Windows being, I believe, the Universal Windows platform. Also, and there is a SDK core, which is required and is a dependency of both the Android and iOS package, right? So you need to add that also, and that would take care anyway of resolving those dependencies if you forget. The Azure Spatial SDK also provide a few functionalities out of the box. First of all, it allows you to do multi-user experiences where you share the anchor data in between users. And like this, if you are, for example, within the same room, which is something that John, Vanessa, and myself wanted to showcase, is being in the same room and sharing content across multiple devices. Unfortunately, John is in Buffalo, New York, Vanessa is in Brighton, and I'm in London, so we're not often in the same room, or unlikely are going to be in the same room anytime soon altogether. But that's how you would do it, by sharing that anchor data. They also provide wayfinding and persistent virtual content. So this is the cloud anchor, the spatial anchor, sorry, that I'm going to be showcasing in the next demo. There is a spatial anchor sample on GitHub and a quick start. The quick start is similar to what I'm going to be walking you through today. So the life cycle of your spatial anchor application, or using spatial anchor in your application, is very similar. You need to authenticate first. Microsoft is slightly different. They use a account key, access token, and a the location. So you need to specify in your Azure backend where you want to host that data. So for example, for me, that was in Western Europe. You create a cloud anchor using AR Foundation. You find planes, you place your AR Foundation anchor, and then you ask the Azure anchor service to specialize that anchor and save it once it has enough data to position it accurately in the real world. And then once you want to retrieve that anchor, you use the locate scenario where, just like before with Google, you scan the environment. If it finds a match, then it's able to place the anchor. You get a callback telling you that this is ready to go. And we're going to deep dive, but I want to show you the application first. And just to be safe, I did some captures ahead of time. So here again, I am near my house in Islington, London. And you can see that I placed this anchor in these little pathways. I am scanning first to get planes, then tapping. This puts the chicken in the middle of the road. And then you can see here the data. Hopefully, it's smooth enough for you to see the text coming up, but the service returns a precision kind of like meter, letting you know that they have enough data to specialize that anchor safely. And then once you get that event, you can request for it to be created on the Azure backend, and that's it. You saved. Then when you look at the anchor again, you retrieve that ID, or you use that ID, which is a string, the unique name of that anchor, request from Azure to locate that anchor. And as you can see, it's pretty fast. As soon as it finds enough markers, these are two different sessions. I shut down the app and restart it, right? It's not within the same session. You can see that the anchor appears immediately and is pretty much spot on where I left it before. And yes, this is, I don't think I have the squeaky sound, but when you tap on this specific anchor, you get a nice little particle effect in order to, celebrate the success of this little demo. So let's dive into the project quickly for this. And there it is. Again, I'm in Unity 2021.3. I'm going to pop up my notes in order to follow along. I've used the Azure portal to create a new resource, right? So this and also added the spatial anchor resource to create a new project, and added a spatial anchor resource to the portal. That I clone their sample repo, which they provide, and we have the link in the slides. And opened it with 2021.3, and then technically before you open, you're supposed to use the mixed reality feature tool, because that's what's going to allow you to add the two packages, the Anchor SDK Core and the Anchor SDK for Android, since I'm developing for Android here. And then inside the asset folder, there is resources, there is a authentication object where you add your account ID, your account key, and the account domain where you're going to be hosting your content. So all of the code is in this component here, Spatial Anchor Demo. Let's look at it quickly. And Spatial Anchor Demo has a dependency on this Spatial Anchor Manager, which you see here. That's this component. That's the one that's going to take care of retrieving all of the authentication data in order to connect to the service, and then provide you with the interface to communicate with the Azure service. So you don't have to do that manually. This takes care of all those communication, including sending the spatial data in order to save that anchor's location. So let's go into the code quickly. Application is pretty simple. I set up, and for those of you who are new to C#, this is a mono behavior, which is a component that's attached to the object. And I basically followed loosely what Google had set up in their example and recreated it here, because the sample project that they ship is a demo of all the features of Azure Spatial Anchor. So it's much wider or much broader than what I wanted to focus on today in the limited time that we have. So I created this custom project, and yes, I'll be uploading this to GitHub this week, so you can have access to the source code. So demo state, basically this variable state stores the state of the application. We start with start, and then we either place an anchor, we create a spatial anchor, which is when we send the data to the backend in order to save that anchor data, that local anchor data, save it on the cloud. And then we locate an anchor where we're going to try to compare the local data with what saves on the cloud, and then trying to reposition or to place that anchor in the real world back where we had originally created it. There's a few editor managed variables here. So these are variables that you can see in the editor here to link objects that are in my scene. Specifically, the main ones are the 4 UI views. You have the start UI, the place UI, the locate UI, and then the create view anchor. So these are all under this canvas here. Very simple. We have a start view. We have a place view. You can see it's just basically a set of buttons that I'm using. Then the create here, this text field will let me know, give me the feedback from the Azure backend, let me know if they have enough data, right? So they basically ask you to walk around, capture as much as possible of the environment. And then the locate view, which allows me to basically, it's going to try to look at all of the anchors that have been saved previously, and then I can also clear that history if I want to start from scratch, right? So that's the idea with this. And we start obviously in the start view, where we have the option to either place anchors or locate anchors. And a little eye icon here is a text field that's in the overlays, which is a debug panel where the debug text is shown, because when you're outside in the wild, you don't have access to the device's logs. So this is easier to see what's happening if something is not working with the app. Next up, we have this is the normal game object lifecycle. And then we have a public API here, which are basically functions that I can access from the UI to restart the application, basically go back to the start screen, to enter the place anchor mode, the save anchor mode, or the locate anchor mode, right? So these are public functions. I can also clear the history from the UI. So this is an open function. Very simple. It's pretty linear as far as a app is concerned. Then we go into the Azure session management. So this is what's going to start the cloud session when you want to start basically communicating with Azure. So that's going to trigger a async procedure to authenticate with the Azure backend. You can also obviously stop the session. This is based on the example that Microsoft provides. And then we have the demo lifecycle, which is initialization, updating the state of my application based on the new state, right? And then updating the UI, for example, but also creating the spatial anchors. So before we go there, there's a few other functions you can see here. Maybe I can make this a little bit bigger, actually. There we go. These are the event handlers for the Azure service, right? So when you get logs back, for example, from the API, when the manager is done locating an anchor, when an anchor has been located, the main one that we want to follow along is this, right? Which is, inside the anchor located, that an anchor has been located. That tells us like, hey, I found an anchor. And then at this point, you can use that to basically place your actual 3D object that you want to showcase in the scene. So these are the convenient method. Everything else is pretty much just debug text plus some utility functions, which we'll cover later. Some of the main functions is, as you can see, add a found cloud or spatial anchor to the scene. Here, you see we instantiate our anchor prefab, and then we use this component, which is on the prefab. It's called a cloud native anchor. And we have this magic function here, which allows you basically to take the spatial anchor that comes back from the Azure backend and apply its position rotation in the world to your local anchor automatically. So you just pass basically the cloud anchor to this function and it takes care of placing it. And then I just add it to a list so I can track everything that has been found, right? But this is really convenient because you don't even have to kind of, manually update the position and rotation of the object. The API takes care of that with you. And there's a reverse function, which is native to cloud, which basically is what Azure uses to take your local AR Foundation anchor and send that to process that from the local Unity space to the geo-located or geospatialized, I guess, position of your anchor in the Azure cloud. So these are some of the key functions, which is really great. And this one, create spatial anchor. This is a really a beefy function, which actually takes and you can see here where we're going to go from the native anchor, which is the local anchor inside Unity, basically, that is not spatialized or geolocated. It doesn't know it, it's just inside my 3D Unity scene in AR Foundation. And using AR Foundation, sorry. And we take that local object and we're going to send it to the cloud to be positioned globally based on the geolocation of the device, of the orientation of the camera, and on the feature set that are around us in order to be able to later on locate it back to that location. So it's very powerful API and it's abstracted by those, few functions. And here we can see we have a little while loop where we wait and for the backend to tell us, hey, I have enough data to safely locate that anchor. You can tell the user that, I'm ready to save and create that anchor. And once that happens, we go into this function where, again, there's a lot of async call, so it doesn't block your application. An async call to basically create that anchor on the Azure backend. And once that's done, you can store it locally. In this case, I am using the same exact system that Google is using in their sample. So I'm storing it to player prefs, which is an old Unity API where you can save data in between sessions of your application, used a lot for games, etc. It's not super secure, so be mindful of that. But you could just push it to a Firebase, to your Azure database, and then share it with other users that later can walk in that same space and find those anchors. So this is how you would do it. And here, basically, the main thing that matters is this ID, which is the unique ID provided by the Azure API that you then send back to the Azure API. That's all you need is that unique ID, and you'll be able to, within your resources for this application, get you the data back. And then you can see here we use a JSON utility to serialize back and forth with this spatial anchor collection, which is basically just a simple class that has a list of our spatial anchor history. And these are these objects here. Oh, that was a meaty presentation. There we go. Any question on this?
Yeah, we've got a bunch of questions in right now, some that were submitted a little earlier, but first one up here is, does it also work for WebGL?
Not that I know. Unfortunately, at least not in Unity, but there might be other solutions out there. Although, to be fair, yeah, I don't know, the geolocation of content, that's definitely supported. The visual positioning, because that accesses, obviously, camera data, but also 3D position camera, right, relating to the physical space using the ARKit, ARCore, or the HoloLens API. I'm not sure if there's an equivalent for the web, right? But geolocating something at a latitude, longitude, for example, and elevation, that's definitely possible.
Yeah, awesome. All right, let's just go through a few more of our questions here.
Yeah.
Once you've set up your scene and deployed it, how long does it usually last? And how many people can access it at once? Can it be shipped via website?
Yeah, I mean, the anchor, you specify a lifetime, right? So you can say 30 days or you can say 7 days, right? And then the backend will automatically delete them after a while. Once they are created, they're basically part of that resource set inside Azure. So as long as people are able to authenticate with the service and retrieve those resources, then they're able to use the Azure API to retrieve to request that a location of to locate basically a specific anchor. And Azure also has a really neat filter which allows you to locate nearby anchors. So if you're in a specific location, or if you detect, for example, specific features, and you can request the list of anchors which are nearby, and then we'll return that list, and then you can start locating those also. And again, to share them, it's just the ID, as long as you're authenticated with the Azure backend. Then using that ID, you'll be able to attempt to locate that resource again.
All right, awesome. Okay, next up here, so I guess I'll kind of rephrase it a little bit. Do Google anchors allow for multi-user AR experiences?
Yes. Once you have the anchor, you can actually, in the Google app, it's really great because once you create your anchor, it actually pops up a share little screen, the sample app that they ship with the Unity package, the AR core extensions, that allow you to share that ID, copy it, and then send it to someone else with that same application. They're able to paste it into their application, and then if they're next to you, they can immediately start locating the anchor, and are you both looking at the same object in the same location at the same time if you want to.
All right, awesome. Okay, next up here, can we speed up the process using Azure? And can you just share your insights and experience?
I don't know what you mean by speeding up. The saving and retrieving of the data is really dependent on the quality, basically, of the capture, right? When you're there and you're scanning the environment to get feature points, and obviously, if there's only enough lights and stuff like this, that's going to affect the performance. Mine was like either overcast or, as you can see here, quite sunny, and it was really fast. It takes less than 30 seconds to probably create an anchor once you have placed it with the foundation. And then a few seconds, not even, a few seconds to actually retrieve it. So it's really, really fast. And again, the authentication is async, but so far I've, even in the wild, when I was scanning the data, it never took more than, I would say, more than 10, 15 seconds to actually create the original anchor. And then just a few seconds, it's almost instant with both the Google and the Azure APIs when you locate those anchors.
All right, excellent.
I'm sorry, the GIF in the middle, and maybe I should go to share and for a second optimize for video clip. There we go. The GIF in the middle is not sped up, right? This is in real time, and you can see that as soon as I turn around, that's why I do this dramatic turn. As soon as I turn around, the anchor just pops there because that data has been recognized by the Azure API. So it's really, really fast.
Yeah, for sure. All right, we keep on going with our questions here. How do we access the depth map, machine vision, not LiDAR, from AR Core in AR Foundation template apps?
So that data, I don't think is available out of the box to AR Foundation. Maybe John, but it's provided by the either ARKit or AR Core API. And you should be able to retrieve it using their extension packages, right? if it's available. I'm not sure if it's available on AR Core. I think ARKit gives you that. They also give you segmentation. They give you a whole bunch of data which allow you to do occlusion, for example. I'm not sure it's supported out of the box by AR Core. So that's something that maybe you can ask in the forums in today's thread, into this session's thread, and then we'll research that for you.
Absolutely. Okay, love to see all these questions coming into the Q&A as well. We've got a ton to go here. I just wondering, Jerome, were you like officially in Q&A? What do you say? Or are you gonna maybe hop around a little?
Yeah, I think I have one more section to go through. We should be pretty fast, but yeah, I mean, I'm
Okay, cool.
open to.
All right, we'll just keep the questions going for now then. Is there a solution for locations that don't have a publicly accessible geolocation?
Markers. I think that would be the best, either object or markers recognition, right? That has no dependency on this kind of backend APIs. So yeah.
Sure. Next one up, are these APIs only for use with Unity?
No. They each of those has a iOS, Android. Azure has also a HoloLens, so UWP, Universal Windows Platform API. I believe they also have a Windows API probably for that data. But both of them, the Google Cloud Anchors and the Azure Spatial Anchors, have dedicated packages for Unity.
Excellent. Okay, is there a file size limit?
No, there's a limit of how many anchors you can locate at once. So when you ask for locating anchors, right now I'm either passing one or a few anchors in a list, basically in an array, the IDs. I think Azure is 40 maximum at once, but you can store as many as you want. Obviously, they want you to store, a whole bunch, because like this, you use resources and then they get to bill you. Because these are, usage-based, metered cloud services. So no, there's no limits, and the data is the visual data that's being sent, the feature points, etc., is driven by their API. So they I guess they get a data stream, process it, and then that's it. There's a usage of resources, obviously in your backend when you geolocate those anchors. But other than that, they take care of the data management.
All right. Okay. Geez, lots of questions coming in here.
Perfect.
For those who are new at all this, why would someone choose Azure versus Google?
Depending on what your employers is using, pricing. Maybe don't use both if it makes sense, if you want to hedge your bet, or not being a single tenant, a single tenancy, sorry, application. It's up to you. Check out the commercials. I haven't looked. I'm using the free tier here, so I'm way below the start, where I use enough resources to have to bill, basically. I mean being billed. So yeah, we don't have preference. We have partnership with both Google and Azure. That's why I showed both.
All right, cool. Next up here, what's the pipeline to accurately applicate an experience in a public place for an indeterminate time with the functionality of occlusion? For example, you want the object to disappear if there's a tree blocking it.
So the best occlusion I've seen was with the Lightship ARDK. We tested this. They have their own occlusion system, which is really great, and also segmentation, as I mentioned. So that's from the Antic, right? And we shared those details at the beginning of this session, and previously also, because we covered them in the getting started with AR. But I believe both AR Core and AR Kit provide occlusion. So that's out of the box, basically. As far as the length, I mean, the lifetime of the application, again, as I mentioned, when you create those anchors, you request how long that data should be saved. So, put 999 years, and then that should take care of expiration. Check out the docs as far as if there's limits from the services, and then depending on your use case, you can precisely retrieve that data and anchor your content back for any users in the location where the experience takes place.
All right. Hey, what's the state of retrieving cloud anchors from faraway places, like a tall building?
You'll have to try. I'm not sure. I haven't tested this. I was trying at a pretty small scale. Give it a go with your device. Try to place something on top of a building, or the main issue is when you create the local anchor. In this setup, when you create the local anchor, obviously you're using our foundation, which maps the environment around you, and it's probably not going to map that building that's a half a mile or a mile down the road. So in this case, you may have to use a geolocation API, either with Azure or Google, which allow you to basically place a point at a specific position on the map, right? Latitude, longitude, and then elevation in your case, if you want to put it on top of the building, and then use that geolocation API, which also use visual positioning. So basically, like Google uses Street View to estimate where you are, what you're looking at, right, with your phone, and then being able to place content in a specific location. So that will be the other, which is the geospatial or geolocation APIs. What we did here is more like a local, near the user spatial anchoring.
All right, excellent. Hey, are there any flaws using it indoors, since the GPS is not always great inside?
No, it was great. I was debugging in the office, and it works flawlessly. It's really good because it actually it uses geolocation to, or at least the coarse one, to sort of find the nearest anchors, but it uses visual positioning, which are the feature points, like the actual little point cloud that you get from the AR APIs, the AR Core or AR Kit, to recognize the space, right? So as long as you haven't, moved walls or, completely redecorated your space with new furniture, it should be able to find the same feature points and then anchor them locally. These anchors, specifically the Azure ones, are to work with HoloLens, which are used indoors mostly. So they have a really good precision level when it comes to indoor data.
All right. Actually, that ties into our next question. Does this build for mixed reality, such as HoloLens?
Yes, the Google doesn't, but the Azure spatial anchors are. You can do native HoloLens development, or you can do HoloLens development through Unity. Right, it supports both.
Right. Okay. All right. Keep on going with our questions here. Is there any way to use cloud anchors and tie to a specific object, like a mannequin?
Well, if you look at the first demo that I did with Google, that was next to this water fountain. I don't know if it's tied to the water fountain, honestly, but it uses the water fountain as a feature in order to save and locate those anchors. So try it. I know that Azure has a precision anchors also that allow you to kind of like define precisely up to the millimeter where you want to place content. That might help you doing this. But I would think that if the mannequin is the feature point, you should be able to overlay content. When I was testing on my desk, specifically with Azure, but I'll probably do another round of tests with the Google API to validate this. But the Azure one, in between session, if I wasn't removing, or during the same session, if I wasn't removing the previous anchor, it was pretty much on top of the previous one that the new one would be located, right? And the rotation was a little bit off, but maybe you can sort of, have a process that refines a little bit the anchoring, right? Or worst case, use markers to combat any drift, or so you use the anchor to the special anchor to re-pull the content and place it, and then a little marker on the mannequin to sort of fine-tune that position.
Yeah, sure. Hey, so these, pardon me, so these anchors, are they visual or positional? At best,
Positional.
use case, okay.
Both way. Visual by the recognition system using visual data, but the actual 3D object, the API doesn't care, right? Like the my chicken is not saved on either Google or Azure. This is just a local representation of that positional data, right? So you have to manage that yourself, right? If you just get the data from Azure, all you get is a position and rotation in space, right? Basically, and then you need to use that to place you on objects. What's great also is because it's not saved. As I developed, for example, originally there was no lighting in there, etc. So I went back, updated the lighting to be reactive to the actual physical environment. And then, when I place my anchor back, because it's not tied to anything in my application other than that unique ID, it all works, right? So when you pull back the data from Google or Azure, it's just try to find that ID, that anchor with ID XYZ, and then if you find it, just give me the position rotation so I can place my object where I had saved it originally, and that's that.
Okay. Now, can we also attach metadata to anchors if you wanted to retrieve specific prefabs or asset bundles elsewhere?
I don't know if you can add additional data. You would have to manage that yourself. I would, with a file-based database, for example, where you take that unique ID from the backend and save your associated data, and then retrieve it later. Yeah, that would be something that you have to do.
Okay, cool. Are there any important steps that one has to do by building it for iOS or Android?
Yeah, making sure that you have the correct SDKs installed, etc. Right? ARKit and ARCore have tighter requirements than traditional 2D or 3D Android applications. So there's a minimum SDK for both. So check the docs depending on what you want to target.
Yeah, sure. Okay, Microsoft has its own MR app builder. You can build using Power Apps, and it's no code based. How different is it from Unity?
I don't know. I'm assuming it's vastly different.
Mm-hmm.
Yeah, the main difference with Unity is you can build apps for about 20 platforms, right? Not only the HoloLens. So that's the main difference. If you want an app that's going to run on multi-device across platforms, etc., then Unity is a good choice for this, right? And that's what we try to demonstrate in this series. Now, if this solution works for you, the more the merrier. It's actually really great, right? It's important to have low barrier of entry tools in order to enable creators to create application. And post your feedback on the forums. I'd be keen to find out if people have used this type of tools, what they think about it, and if they tried Unity, what's your opinion and differences, and what you liked or dislike about both processes. That'd be great.
Absolutely. All right, last question on deck here. Would this be available for anywhere on Earth, as Street View might not be available for some places?
So this specific anchoring system does not use Street View. That's the geolocation API that would use this. Specifically for Google. Again, there's an example of this with the samples, right? So there was the persistent anchor sample, which is the one that I showed, but there's also another one, which is geolocation sample, and that uses both Street View for visual positioning and your latitude, longitude, and elevation for geographical positioning. So it's slightly different, right? Where I guess it's wherever both APIs are available is dependent on the service. Just check the docs. They probably have coverage services. For Azure specifically, you have to specify which server you use when you set up a resource. So this is for Europe. If you want to have a dedicated resource that hosts in the US, then you would have to do that also. They're very segmented when it comes to data, due to data protection regulations, obviously.
All right, excellent. It looks like that's it for all of our open questions in Q&A.
All right, well, then before we go into overtime, I have my obligatory, that's it for the road to the metaverse, since we are already at time. We're going to overtime and I have another section, so don't go away. We're going to cover Unity as a library, which is really useful. But I wanted to do a quick wrap up of the series because everyone here and those who are not also, I've worked hard in delivering not one, not two, but 24 workshops over the last 12 months because there are two series. There's actually this creator series where we did deep dive into sort of like wider topics. And then there's the Learn Live or Live Learn series where you zero in on specific features of Unity. And believe it or not, these are all the people that have contributed to this series, starting with my co-host and partner in crime, Ben, Drew, John, obviously, and Vanessa that are here, that have been on this series, but also Joy and Thomas that helped with the Live Learn. And then there's a whole slew of people which are working behind the scene, and I've listed them. There are Bex, who helped her with copywriting, Carol, that orchestrated all the campaign, Caroline, Derek, Holly, that was on the same team as me and Drew, and John originally, Isabella, Jeff, Justin, Kathleen, Katie, Stoke, Brilliant, who was the program manager, Levan, Rita, Nick Davies from content marketing, Sabrina Shiraz, who's the technical artist on John and I's team, and Vanessa with 2S, that does a lot of the orchestration in the back end. These are all the people that have worked on this series. I would say, Drew, would you agree, this vastly successful series?
I think so. Yeah, absolutely.
So should we revisit the pitch? Because I think it's important to remind ourselves what we did last year, because Ben and I, we kind of incubated this series in December 2021, I think, or so. John, I think we were all pitching together to create the series back then. And the road to the metaverse, basically, that was to look at how do we empower you with the skill and knowledge to be successful on the metaverse. And let's look at what we have covered in the series. In case this is your first time, then you will be able to see what we have done before and what you can go and watch on demand. Well, we're getting started with Unity. That was the first session. We kind of like lay out the groundwork for the series. Then we looked at importing assets inside the Unity editor, either digital assets or physical assets, like capturing, scanning, etc. But also asset optimization with our brilliant suite of tools, Pixies. Adding interactivity, we started looking at visual scripting. So if you people mention low code or no code, most of this series has been driven with visual scripting. We created a virtual showroom, and we also looked at creating custom nodes with visual scripting, because you can extend that if you can code for the non-coders on your team. Then we looked at ingesting real-time data like REST APIs, doing web requests, and we created a wind turbine simulation. This is actually still available on Furious, so you can try it online if you go through the slides. I think it's on the forum thread. I have it down. Ben did a whole session with Vanessa. Actually, I think that's when you started, Vanessa. That was the introduction to XR, all VRs.
I believe so, yeah. With
Yeah,
Euphoria,
that was your
actually. I
first.
think so, yeah.
Yeah. And then, yeah, the session after that, you did your first, I think, live demo, which was the PTC Euphoria one. Congratulations on that. And this is a GIF from creating the HoloLens version of this app. So that was on the HoloLens. We showed you how to do this. Then Ben went wild in creating a VR environment and using visual scripting with the XR Interaction Toolkit. So this is a custom visual scripting library that we created for the series. We did a immersive training experience that was lots of fun, where we looked at creating a step process in VR in order to basically snap back wheels and also explore the use of state machine. Again, more HoloLens AR training with MRTK3. Good news is I hear that Microsoft has assigned a new team to develop MRTK, so they're going to keep developing the framework, which is super popular. So that's great news. And this is really useful, and also is chock full of features that are really great. IoT data, that's when John joined the series officially and helped with a brilliant hardware sensor demo using Arduino and Unity. This was really great and well received. And then we looked at using MQTT to broker all of those IoT data inside our demos. This was probably my favorite session when we dove into netcode, which is a really complex topic. So thank you, John, for making it seamless and super easy. But also Vanessa and I had a ton of fun working with Normcore and Photon and sort of like surprising each other in the editor, which was still probably one of my favorite moments when I pressed play and Vanessa was in my scene and I was like, what the? That was great. And then today, well, with geolocation, mapping, etc. I'll include with the slide all the stuff we did in learning. So these are all the other webinars. We already covered those. As usual, don't forget about the GitHub, Road to the Metaverse. Today's source code for the special anchor will be uploaded there. So I'll notify you in the forums, right? Very important. Join the discussion, join the forums, go back and find the content. And I think I have a thank you slide, but I don't think that survey is the right one. So I'll just go into the overtime just in case there's no questions.
Yeah, a couple of questions quick here. What's the plan for the next live learn?
We done with live learn. We finished that 2 weeks ago. We did introduction to spatial audio, actually, which was really fun. Joy joined us and covered using playable, using timeline in order to drive sound. So that was really fun.
Awesome. And one other question, will there be an extra session on AI and implementation?
That'd be great. I don't think so. Maybe something you can cover in Creator Days, Drew.
Yeah, maybe we'll cover all kinds of stuff in Creator Day. So you never know, we might see something like that.
Definitely a hot topic, right?
Mm-hmm.
All right. Well, we have 20 minutes left in overtime. So maybe I can jump into today's bonus demo, Unity as a library, unless there's more questions.
No, all good.
All right.
Go on in.
So I wanted to mention this because this is quite important. Actually, this is quite fundamental. Unity is great to create applications, but often, specifically when you want to just embed, for example, a little AR feature inside an existing application, it makes zero sense to rebuild the whole thing in Unity. So you may have a native Android and iOS app, and you want to add a specific feature which Unity will unlock, then you can basically embed Unity inside your native app, and you do that with Unity as a library. This has been around since 2018. And Unity 2019, actually, officially, I guess, supported. And this is actually, this has been around. This has been supported officially, but it has been the way we export Unity for iOS, because for iOS, you cannot build directly from the Unity editor. For Android, you can export an APK straight out of the Unity editor, but for iOS, you have to go through Xcode. And to send the Unity project to Xcode, we just export a Unity Xcode project with Unity as a library included, and then from Xcode you build that application to your iOS device, that app. So that's been the way for iOS, but you can actually use that also on Android and on Windows for HoloLens, because that's also the process for HoloLens you build through Visual Studio, or at least Visual Studio command line, because you can build directly from the editor. It looks like you're building directly from the editor, but in the backend, it uses Visual Studio to build that application. So you can, rather than do that implicitly, you can do that explicitly by, specifically in this case for Android, asking Unity to export a Android project versus building an APK. And I'm going to show you how you do this in a minute. But in this case here, how it works is you have a Unity project. And when you select to export a Android project versus build directly an APK, you export that project as a native project, and then you can include that project inside your native Android application. You can link to it and add it to your application. We have sample implementation of all of these available on GitHub, including a sample Unity project with a sample Android and iOS project inside the same repository. And under the hood, this is how it works. So I'll be showing again my trusty chicken for this session, where you can see here, I have the Unity player in the background. And on top of it, I have a native Android UI. We are going to go live to my phone here. So this is the phone that I have on my desk. And you can see here, I'm inside Unity as a library demo. This is a sample project that we ship. It's not super pretty, but it does the trick. I just click on Show Unity. Hopefully that's going to update. There we go. You can see the Unity application started. I can scan my desk again, and you will see the AR Foundation planes appearing. Then I can place my trusty chicken. Let's place it a bit closer here. And then this is the Android UI. So when I move my slider, I am rotating my object inside Unity. So from Android, from the native Android application, I'm able to send messages, to send command to the Unity player and control my objects inside Unity from the Android native application. And that's a really good example of how within your native application, you can embed a nice AR core or an Android AR core experience with Unity, right? And then keep basically the lifecycle of your application. In here, the finish button, basically, when I tap on it, it kills the Unity view and takes me back into native Android, and I'm done. So it's a really good way to work with Unity on native platforms. And let's have a quick look. So let me grab my notes. And we're going to start in Unity. So this is this project that I've shown. You can see it's a regular AR Core template project. If you're wondering, AR Core is basically, AR Core is the XR plugin for Android, but confusingly, it's also a template that we have inside the package manager, inside the hub, which pulls all of those plugins for you. That's all it does, right? It bundles those plugins. So AR Foundation, AR Kit, AR Core, Magic Leap, AR Face, AR Kit Face Tracking, and then the OpenXR plugin pulls all those packages into your project from the start, so you don't have to do it manually, right? Then after that, all I did is set up my AR session the same way with AR session, AR input manager, my AR origin with my AR camera, and all the components that come with it. And then here I have a little script which is called place on plane, which we used before in the series, which when I tap of one of the planes that's recognized by the AR plane manager, it's going to place that object, which is my chicken, on that plane. Right? Super simple, straightforward AR application. Now, a few things you have to do when you go into edit and project settings. So let me maximize this. First of all, when you work with AR Core, you want to remove Vulkan. If Vulkan is your default rendering stack or graphics API, you need to remove it. You can also probably remove OpenGL-ES2 since that's deprecated anyway. I don't know why it's still there by default, but that's the first thing you have to do. Obviously, as usual, name your update your company name and the project name. Also, make sure that you are targeting Android in this case, because I'm developing for Android. By the way, this might be checked, the automatic graphics API. Make sure to uncheck it, and then that's where usually you find out that Vulkan is included, and that's usually the root cause for a lot of issues. In this case, we also set the minimum to 24. A minimum API level for Android to 24. I believe that's the minimum. It's either 22 or 24, which are the minimum for AR Core to function, at least with Unity. and then send my scripting backend to IL to CPP. This is where Unity is going to transcode, convert all your code to an intermediary language, and then upon compilation of the application, it's turned into C++. Then finally, normally this should be unchecked. So remember to check ARM64. It's actually a requirement for Android that you include this target architecture these days, because most phones are actually 64-bit. So that's for the project settings. Usually you have to do that every time. And then if we go to our build settings, obviously I switch my platform to Android. And then you can see here, normally this is unchecked, export project. So you can build your APK directly. And here, rather than build, I'm going to check export project, and that's going to allow me to export my project. And if I go to my file system, when I do so, I'm not going to build now. It's pretty fast, but basically what I did is I exported inside this. I checked out the Unity as a library example repository from GitHub. And then I have this Unity editor export. That's where I exported my project. And you can see there's a few traditional Android project files. You have Unity library, which is where Unity saves all its stuff. You have your Gradle and build settings, etc. are all done as usual. But this is not the project that you are going to use. I want to use the native Android app. So I open this inside Android Studio, which I have open here. Looks very similar to JetBrains Rider because it's based on JetBrains Tech, if I remember correctly, Android Studio. So here, basically, when you open your Android Studio project, you need to reference the Unity library, and you do all this inside those Gradle, and the various setting files that you have for Android. And here you can see, for example, that as a dependency, I need to include my Unity library, which is this folder here, right? That gets referenced, and I have to tell the application where to find that stuff, right? So that's the main thing. Also, for example, here is to make sure that you include the NDK. So if you're not familiar with Android, this is quite complex, but it's very, step tutorial that I linked in the slides that walks you through this. One thing that I did is adding these lines here, which asks Android not to recompress our resource file where we bundle all our assets. We don't want this to be compressed. If you can't access, for example, resources in your projects, that's probably why they've been recompressed by Android Studio. So you just put that directive and it's going to stop Android Studio from doing this. Again, these are pretty simple things like pointing to the right SDK and NDK, updating your manifest file. This is quite important if you work with Android. Here on the manifest, there's a few things that you need to add for Unity for AR Core, including that mentioning that AR Core is required, that you need the camera, and things like that, right? You see here, for example, I ask for the user for the permission to use the camera. These are all like native Android things that you have to do. So a few settings that you need to update. And then basically what happens is once everything is done, you just sync the project, and this Unity library folder will show up, and that's where the Unity magic is, right? And then inside that project, you have the main activity, which is your normal Android stuff. So if you're not familiar with this, probably it looks a little bit scary, but you don't necessarily have to worry too much about this. This is the main activity. This is basically what gets launched when my application starts. And you can see that there's a few buttons to load Unity or to unload Unity. And then this is my actual Unity view, which is pretty simple. And in there, you can see there's a SIG bar, which is that little, let me go back to my phone here. So if I show again my Unity activity, so that SIG bar here, this is the SIG bar, and this is the button finish that you have there. And if I place, I need to scan a little bit my environment here to be able to place content. And then if I placed the sig bar, basically you decide, a value. This is from 0 to 360. And then that's here you can see a event that says on progress change. And then you have this magic line, which is basically the only thing that's really important here, is using the Unity player class that Unity provides for Android application. I use the Unity send message to the Unity player, and I pass 3 arguments. One is the name of the object that should be handling that message inside my Unity scene. The other one is the name of the function on that object that's going to be called. And then the third one is the value that I want to pass. And in this case, I pass the value of the sig bar, which is in between 0 and 360. And if we go to our Unity project and I double click, we have message handler here, which is the object reference here, message handler. So this is this object, and then it has a script called update rotation that takes a string value. I take that value and I convert it to a float because that's what my rotation wants. And then I find basically an object with the tag AR placed object. So if there's multiple ones, I'll take the first one of them, which in this case is my chicken, and update its rotation based on the value that's been passed. And that's how you link your Android app to your Unity runtime. And yeah, this is pretty much it. And again, this is something in the past month I've used for 3 customers. For demonstration, a lot of our customers have native applications, specifically Android apps, for automotive, for example, because there's Android Automotive OS, and they want to integrate Unity features inside those platforms. And that's the best way of doing so without having to rewrite everything from scratch, right? So yeah, that was it for the demo. Again, very, very powerful feature of Unity. It's supported on iOS, and you can also use it for HoloLens, right, using those mixed reality.
For sure. All right, we've got a few more questions that have rolled into Q&A, so maybe just
Awesome.
answer a few questions, and then we'll call it a day here, wrap it up. All right, first one up. Does it work with Flutter UI?
Actually, if you look online, a lot of the questions are people trying to figure out how to integrate Flutter with Unity inside the Android application. Yes, it should. Basically, it's as long as the resources are there. Obviously, Unity has consumed quite a bit of RAM and resources when you fire up that activity. So as long as the resources are there, it doesn't matter. The whatever you put inside the Android app should communicate. You just have to link with that send message within your application. I did an integration for a customer where we use fragments. So fragments are like like partial activities. And the idea of fragments is they're really tightly separated. So they don't know about each other. And it's really hard. By design, it's really hard to have 2 fragments linked to each other. So you need to use a model, like a view model. So this model is shared between the 2 fragments. So if you have your Flutter application and you want to send data to Unity, you could use a Unity fragment that observe this model, and then from your Flutter UI, update the model as needed. And then, when the view model updates, the fragment send that data to the Unity application, and boom, your Unity application responds to the UI, right? But they don't have to be aware of each other. You can be completely separated.
Okay, cool. Okay, next question up here. Using embedded Unity applications is it lighter than an app generated from the Unity editor? Clients tend to complain a little about Unity apps' large sizes.
Yes. So if you want to reduce your file size, your Unity file size, be mindful that most of it is assets. The player is pretty much a fixed size, a few megabytes. I think it's up, depending on the platform, it's like 5 to 20 megabytes, I think. That's the size of the player. Everything else is usually your assets. So mostly, textures and things like that. So there's a few ways you can really, I recommend you look at asset bundles and addressable assets to externalize your assets as much as possible. So your Unity application will ship basically with just whatever is needed in the first scene that it loads. That's usually that's all that needs to be bundled, is the content in that scene by default. And then everything else can be sideloaded with addressables. And then you can also use addressables. One great thing about it is there's a tool that we provide, which allows you to look for duplicate data. And often within Unity applications, even you reference data multiple times, they get bundled with different bundles in order to account for your strategy for loading and unloading. And that that tool allows you to find those. And there's a really great, I'll post it in the forum, there's a really great session explaining how they went, our bot demo went for 500 megs to 300 megs just with that, by removing duplicate assets that were bundled in separate bundles. So externalize your asset to make the application smaller, but the Unity player, when you embed it in your application or when you export it with Unity, has a set size and obviously consumes quite a bit of resources. Again, that's something that our engineering team works really hard around to reduce to the maximum. But it's difficult to add new features without adding any bulk to the runtime.
For sure. Okay, next question here. I was recently trying to embed AR Unity as a library inside a Flutter application. However, there are version problems with NDK, JDK, as Android uses more advanced recent versions as compared to Unity. There were no Vulkan issues. Is there something that could be? Is there something that should be kept in mind regarding versions of JDK, NDK, and Gradle before using Unity as a library?
Yeah. Try to find the sweet spot. That's usually where most of the issues come from. So try to export your you can also specify which SDK Unity uses to build, right? To export your builds. So specifically for Android, inside the external tools. Under preferences, you can specify, version of the SDK and NDK, and then you can test with that if it builds successfully your Unity application, and then go from there. When I export in my project, the NDK and SDK were different, right? From the one that was in the editor, but I'm sure there's some incompatibilities. We also have, don't have a slide for this, but we have a new, more modern Android implementation coming out, right? It's called the Game View Activity, I think, or Unity Game Activity. It's a new, more modern implementation of the Unity activity. It's been released recently. I've seen a presentation on it, and it looks really, really promising. I'll post it in the chat actually, because I have it here.
Oh, awesome. We'll just give you a second to find that before getting on to our next question here.
There we go. It's called Game Activity. There we go. It's this is the great thing about Unity and Google. I think since 2011 we have a platform partnership with Google, and we work really closely together to make sure that Unity is packaged as efficiently as possible for the Android platform. So hopefully that will resolve some of those issues for Unity integration inside wider Android projects.
All right, we may be running a little low on time for this one, but can you show us how to embed the Unity library ourselves in case the client shares an Android project and asks us to include some Unity features?
Yeah, it's in the slide. So what I showed you, the native Android project was a separate project, and then you just reference your exported Unity project inside that project. So you don't add it to that project, you don't copy the file. It's an external, basically, reference. So you don't have to touch your customer, modify, vastly your customer project. Don't copy just the Unity file in there. Just use the documentation on the Unity as a library example. There's an Android page, which is in the slides. And then it's referenced as an external library within that project. So if you update the Unity project in between, you don't modify the project where that library has been referenced, right? Imagine basically it's an external dependency that you add to your Android project. That makes it a lot more manageable.
For sure. Hey, I've heard that Duolingo uses Unity. I'm wondering if they also use Unity as library.
I don't know. That sounds fun. I'll have to check it out. Unless the app is made with Unity, specifically like exported from Unity, they probably use Unity as a library for iOS, because that's the only way you can export Unity for iOS. It's an external library because you have to recompile with Xcode. And if that's the case, they probably use Unity as a library for Android, because it makes sense to have, a native UI or use React Native or whatever UI library or UI framework you want to use for your application, and just embed Unity, the Unity player, for the features that you want, things like AR or, some 3D features.
For sure. Hey, is there a training video on how we can use this AR code package and build for Android or iOS or HoloLens from scratch?
The AR Core extensions, they have documentation on the Google website, which is really good. So there's links in the slides. So we'll put those on the forums. Grab them and go check out the docs. But it's the AR Core API, right? There's AR Core Anchor API. That's the deprecated one. Use the AR Core API, and that comes with a set of documentation to create applications for each versions. Azure is the same. You have iOS, Android, and what else, right?
All right, excellent. Okay, just a couple more questions here before we wrap up. Except for the use case you mentioned for specific automotive SDKs, is there any other advantage or use case for using the exported version for Android's Studio compared to using the APK directly from Unity?
Yeah, it's up to your specific use, right? The advantage is that you take control of the integration with your wider application. If you don't need that, then just build directly from Unity. But yeah, that's usually why people do it. It's to integrate within either an existing application, or because they have an application that has more features than just the Unity player, right?
Sure. Okay, is there a plugin to reduce the Unity application workload or vertex count?
Pixies.
Pixies, right? Yeah, regarding the quality for 3D models.
Yes, Pixie Studio has a brilliant feature. It's decimate to target, which I love. So you can tell Pixies, hey, that million vertices model, I want this to be 100K or 10K because reasons. And it can decimate and bake. So that's great. So you get cookies. No, you get normal maps, for example, where they bake the complexity before the decimation. And then you get a low res mesh with high details from the normal map texture. So highly recommend Pixies. If you don't want to use Pixie Studio, which is the standalone tool for agnostic data preparation. So Pixie Studio works, exports USD, USDZ, GLTF, can export FBX, OBJs to whatever platform you need to use. You have also Pixie's plugin, which is a plugin for Unity editor. So that's a editor time plugin. It's not for runtime use, but in the editor, you can do decimation, you can optimize your assets automatically. It's a really good plugin just for the Unity editor. But if you're working with big data sets or complex data, then I recommend you look at Pixie Studio.
Right, excellent. All right, thanks everyone for asking all of those questions. We just love to see that engagement in Q&A, and yeah, just kind of glad that you guys could all join us this deep into overtime. Before we go here, I'm just going to shout out Creator Day Industry once more. Again, this is going to be March 31st, 2023. Half day of webinars going from about 8 a.m. to noon PST on March 31st. And just for more details about the talks that are going to be held during that webinar, I just posted the link in the chat there. You can see everyone's sessions, descriptions, bios of all the speakers, and register there as well. So please check that out when you get a chance. And yeah, with that, thanks again, everyone joining us for today's session. Jerome, of course, thanked everyone involved in the series earlier. And yeah, big thanks to absolutely everyone who came together and made this series possible. It took a lot of work and took a lot of people, a lot of time. And yeah, it's just so grateful for all their contributions.
I gotta say, this has been the highlight of the past year is working with you, Drew, John, Vanessa. It's absolutely fantastic. Ben, who's not here today, but we're thinking of him.
You're in spirit.
Yeah. Thank you so much for the support and for the really fantastic work, everyone. This has been absolutely brilliant. So